Hello! How we doing? How's it going? Today we're going to be looking at one-step inequality word problems and see what do these inequalities look like on a number line. So let's hop to it. So we want to write and graph these inequalities. Our first situation, it says you must be at least 4.5 feet tall to ride the roller coaster. At least 4.5 feet tall. So when we're writing our inequalities, that should be a lowercase I. My bad. When we're writing inequalities, we're always going to need to have a variable and the number in our situation. Our variable x, how tall we are, 4.5, how tall we need to be to ride the ride. So now we have to look at this wording, at least. So if I'm at least 4.5 feet tall, can I ride the roller coaster? If I am exactly 4.5 feet tall. Yeah, I can ride the roller coaster if I'm 4.5 feet tall. So if I can be equal to 4.5 feet tall, I want to put a line there to show it could be equal to. Now I need to decide, is it greater than or less than? So can my height be less than 4.5 feet tall to ride the ride? Or does my height need to be greater than 4.5 feet tall to ride the ride? Yeah, x, we want it to be greater than 4.5 feet tall. At least 4.5 feet means I could be 4.5 feet tall, or I could be taller. Anything taller would work to ride this roller coaster. So when we're looking here, we know we need to start off first with the variable and a number. The first thing we need to write down is a variable and our number, just like we did there. The second step, could it be equal? Because equal is going to give us that line underneath of it or not. Equal, we put the line underneath of it, or not, just the inequality. Then we look at our inequality symbol. It really doesn't matter if you do the inequality symbol or the equal first. Just in my mind, I like to do the equal sign first. That's just how my brain works. Your brain might work different, and that's okay. So now that we've gotten those two things written down, now we want to talk about two heights that would work for this situation. So what are two heights that are greater than 4.5 feet? You can be 5 feet tall. That works. 5 feet tall is greater than 4.5. 6 feet tall would work. 7 feet tall would work. But because it's equal, 4.5 feet also works. Any two heights that are equal to or greater than 4.5 work for me. But now we want two heights that would not work. So I need numbers that are not greater than 4.5. One way to help us see that is if we come down here and we graph our inequality. There's a line underneath. So that means I need to have an open or closed circle on 4.5. Closed circle on 4.5. And then x can be greater than 4.5. So that means any number bigger than 4.5 will work for me. So I need to choose numbers that are down here that would not work. It's like if I'm 3 feet tall, that would not work. I'm too short. Can we be negative feet tall? That's not possible. What about 2.5 feet tall? That doesn't work either. 2.5 feet right there. That's not part of where I shaded. That answer wouldn't work. If you need to pause the video to write any of this down, go ahead and do that for me. Otherwise, let's turn and go to the next page and do another problem. Our next one, it says only children that are less than 6 years old can swim in the kiddie pool. Only children that are less than 6 years old can swim in the kiddie pool. So again, I need a variable and my number for the problem for my first step. My number is 6. For my variable, I'm going to choose C for children. I'm comparing a child's age to the number 6. Child's age compared to 6. It says only children that are less than 6 can go in the kiddie pool. Only children that are less than 6. So let's think. Could it equal 6 exactly if it's for children less than 6? It cannot equal 6. Only children less than 6. What does the less than symbol look like? It looks like this. Children have to be less than 6 to get in the pool. They cannot be equal, so there's no line underneath. Let's graph this one now before we think of ages that do and don't work. So 6 years old, how would I graph this? Would this be an open or closed circle on 6? Open circle, yeah. Open circle, there's no line underneath, so it's going to be open. And then do I want numbers smaller than 6 or bigger than 6 for children's ages in the pool? Smaller than 6. Can we have negative years for an age? That doesn't work. So that's why I stopped my squiggle at 0. Negative numbers, you can't have negative age. That doesn't work. So now looking at answers that do work, what are 2 ages of kids that could go in the kiddie pool? A 2-year-old can go in the kiddie pool because 2 is part of that squiggly line. Can a 6-year-old go in? No, it's not a closed circle. 6 cannot go in the kiddie pool. What's a number that yes, it can go in the kiddie pool? 1 year. If you're at 0, 1, 2, 3, 4, or 5 for can go in the kiddie pool, you're good. You're good there. 6 years cannot, or anything else bigger. If I'm 100 years old, I can't go in the kiddie pool. Anything bigger than 6 would work there. Pause the video. Make sure you've got all that written down. And when you're ready, slide on up to the next question where we're looking at some Skittles. Our next problem, let me get a red pen because this is Skittles. Write and graph the inequality. Each bag contains no more than 32 Skittles. It doesn't have all those questions like I did before, so I'm just going to set up the inequality on my own to help me graph it. So, bags and 32 Skittles are the 2 things I'm trying to compare. Bags and Skittles. My key math words here are no more. No more than. Let me throw than in there too. No more than 32 Skittles. So could it equal 32 Skittles exactly if it's not more than? Yeah, it could equal 32 exactly. Because 32 is not more than 32. 32 would work. It could equal that exactly. Could my bag have more than 32 Skittles? No more than 32 Skittles. So what symbol would go there? Less than. My bag can have less than 32 Skittles because less than would be not more than. Would this be an open or closed circle with this symbol? Closed. It's got a line underneath. So put a closed circle on 32. And then can my Skittle numbers be more than 32 or less than 32? Less than 32. So what direction will my arrow go? To the left. We can have less than 32 Skittles. We can have fewer than that. I could have 20 Skittles in my bag because 20 is not more than 32. Once you've got that written down, go ahead and turn over the page for me. This one we see all the time. The speed limit is 55 miles per hour. No, there is not a law that says you can drive 5 over. If you drive 60 miles an hour, you're speeding. If you drive 56 miles an hour, you're speeding. Limit means that's the most it can be. The speed limit is 55 miles an hour. So we're going to compare our speed to 55 miles an hour. So a speed limit sign. Can a police officer pull you over if you're going exactly 55 degrees? No, they can't. You can go exactly 55 miles an hour. The police officer cannot pull you over for speeding. Can my speed be more than 55 miles an hour if my speed limit's 55, or less than 55 miles an hour? I can drive less than 55 miles an hour. If I drive 52 miles an hour, they can't pull me over. I'm doing everything I'm supposed to. So on this 55, do we want an open or closed circle? Closed circle, yes. I can be exactly going 55 and they can't pull me over for speeding. And then again, speed limit, do I want numbers bigger than 55 or smaller than 55? Smaller than 55. So we're going to go to the left. Pause this video for me and I want to see if you can try this one on your own. It's very similar to the first question. It's about a roller coaster and how tall you can be. This one says you must be at least 5 feet tall to ride the roller coaster. We're comparing our height to 5 feet. Write an inequality for me and then graph it. Pause the video. Good luck. Did you really write the inequality and graph it? Because that was kind of fast. You sure you got it? Double check. If I'm trying to be at least 5 feet tall, that means I could be equal to exactly 5 feet tall, or I could be taller than 5 feet. I could also be taller than 5 feet and still be on that ride. So because it could be equal to exactly 5, there's that line underneath. I need a solid dot on 5, and my height can be greater than, so I'm going to shade it to the right. Shade it to the right. Double check your work, make sure you've got it. Pause if you need to fix anything, but otherwise, if you're good, let's go to the next problem. We're going to skip this one. I don't like it. Skip it. Skip it. We are going to do this one, though. This one says, Fiona wants to give her friends at least 3 bags of Takis each. If she has 27 bags, what number of bags could she give her friends? So again, let's go through this, because this one I like. This one works better. Fiona wants to give her friends at least 3 bags of Takis each. So we're trying to compare our Takis to 3 bags. Nope, sorry. Each, what does each mean, you guys? Multiply. So I need to do the number of Takis times 3, or 3t is the way that we would see it normally written. Takis times 3 bags each. If she has 27 bags, what number of bags could she give her friends? So I'm trying to compare these bags to the 27 that she has total. If she wants to give her friends at least 3 bags, at least 3 bags. Could it be 3 exactly? Yeah, it could be 3 bags exactly. It could be 3 bags exactly. But could the number of bags that she has be greater than 27, if that's what she has? Or can the number of bags that she have be less than 27? Sorry, I think I said that weird. Let me say it again. So these are the bags that she's giving. This is what she has. Can the bags that she's giving be more than the 27 bags she has? Or could the number of bags she's giving be less than the 27 bags that she has? Less than. She can't give away more bags than she has. She only has 27. So our inequality here would be 3t is less than or equal to 27. So we would want to solve this then. Again, this is multiplication. What's the opposite of multiplication? Division. Divide both sides by 3. Those 3's cancel. I get t is less than or equal to 27 divided by 3 would be 9. You don't get into these types of questions until you're in 7th grade with the multiplying and dividing. So this is kind of an extra little tidbit for you. So t is less than or equal to 9. She could give 9 friends 3 bags. Or she can give fewer bags to her friends and give more bags to them. So anything less than 9 would work. You can't give away negative bags, so that answer choice doesn't make sense. If you have any questions on these word problems, please let us know. Good luck with the rest of your lesson today.